All right, so the one rule with adding and subtracting radicals is slightly different than the multiplying. Two things have to happen in order to add them. They have to be the same index, so square root and a square root, cube root and a cube root, fourth root and a fourth root. But also the radicand, that number under the radical, has to be exactly the same in order to add them, okay? If it's a square root of 2 and a square root of 3, those are not the same, so you cannot add those together. If you can't add them, then you just would leave it like the square root of 2 plus the square root of 3. Okay, so for example, with question number 1, I've got 2 square roots of 7 plus 3 square roots of 7. Do I have the same radical? Is it both square roots and both the same number under the square root? Yes. So then I can actually add those. And the only thing that changes is the coefficient in front. And what I mean by that is all we're going to do, all we're going to do is we're going to take these coefficients, that 2 plus 3, what is 2 plus 3? 5, and then that square root of 7 is going to stay the same. The only other thing I would try to do is see if I could simplify any further. Does 7 have a perfect square in it, or can it simplify at all? No. So that's exactly how we're going to leave our answer right there. If my pen would work right. Okay. So on the next one, I've got 3 square roots of 2 plus the square root of 8. Are those the same? No. So then if they're not the same, the very first thing I want to try to do is see if I can simplify to turn them into the same thing. Sometimes you can, sometimes you can't. So start with the first one. Does the square root of 2 simplify at all? No. Okay. What about the second one? Does the square root of 8 simplify? What perfect square goes into 8? Okay. So what we're going to do is we're going to break this one down into the square root of 4 times the square root of 2, just like we did all last week, simplifying these radicals. The square root of 4 turns to 2. Okay. And then I'm just going to bring this other piece down since it did not simplify. Are they the same now? Yes. So now we can just add. Again, we're just adding the coefficients. What is 3 plus 2? 5. And that square root of 2 is going to stay the same. So my final answer would be 5 square roots of 2. Anybody have any questions? All right, I want you to try 3 and 4, actually. 4 is... All right, with number 3, can I add them or subtract them as they are? No. So I'm going to have to simplify. Starting with the 45, what perfect square goes into 45? 9. So that 2 is going to stay. Then I'm going to split up that 45 into the square root of 9 times the square root of 5. Again, the 2 stays. What is the square root of 9? 3. And so that's going to turn into 6 square roots of 5. Can that second one simplify at all? No. So I'm going to bring it down. Now, this is one I always get a couple of answers on that are not correct. Looking at the coefficients only, what is 6 minus 6? 0. Okay, so this is what I see a lot. This is a mistake that happens every year. People put that. How many square roots of 5 is that? 1. What did you just tell me 6 minus 6 was? 0. So if you're going to put the radical, you got to put a 0 in front of it. However, the most simplified answer, 6 square roots of 5 minus 6 square roots of 5, completely cancel each other out, and it is just 0. If you put the square root of 5 without a 0 in front of it, you're telling me the answer is 1 square root of 5. So be very careful with that. And I say that because it happens every single year. 0 square root of 5 is fine, yes. But if you just leave it as just the square root of 5, that is not. Is everybody okay with that? What about 4? Is that one ready to go? Yeah, I both have their cube roots of 3. Those cannot simplify, so I am just going to take and add the coefficients. What is 8 plus 5? 13. So, if my pen would actually write this morning. Come on. There we go. 13. And the cube root of 3 is just going to stay the same. The index doesn't change in the radical. Everybody okay there? All right. try both 5 and 6. You're going to have to simplify both of them. The cube root of 54 minus the cube root of 16. Those are not the same, so we cannot subtract them right now. So what we need to do is find a perfect cube. We're not looking at squares, okay? We're looking at cubes. So remember what we talked about. We're going to start with 54. We want to go to the one closest to it without going over, which is 27. Does 27 divide evenly into 54? It does. How many times? 2. So we're going to split this up into the cube root of 27 times the cube root of 2. And what is the cube root of 27? 3. Okay. Then we're going to do the same thing with the 16. 16 is also not on my perfect cube list. I'm going to go to the one closest to 16 without going over, which is 8. Does 8 divide into 16 evenly? Yes, it does. So we're going to split that up into the cube root of 8 times the cube root of 2. And what is the cube root of 8? 2. Now they are the same, so I can actually do the operation. What is 3 minus 2? 1. So you can put a 1 in front of it like that. Or does that also mean 1 cube root of 2 if I don't write the 1? Okay. Either way you want to write it. If you want to put the 1, that's fine. If you don't, that's fine as well. That is completely different than 0. Okay, 0 has to be there. 1 does not. With 6, we're going back to squares. Is 48 a perfect square? No. So I'm going to go to the one closest to it without going over, which is 36. That does not divide it evenly. Does 25 divide it evenly? What about 16? How many times? 3. So we're going to split this into the square root of 16 times the square root of 3, which is going to turn to 4 square roots of 3. And then we're going to look at 12. Is 12 on my list? Nope. Closest one to it is 9. That doesn't go in, but 4 does, right? So we'll split that into the square root of 4 times the square root of 3, which turns to 2 square roots of 3. Am I able to do the operation now? Yep, they are the same. And what is 4 minus 2? Yeah, except for my pen's not right again. Okay, so 4 minus 2 gives me 2. So our answer is 2 square roots of 3. Are we okay with that? All right, try 7. Same thing, it's just a little bit longer. All right, let's start. Is 12 a perfect square? No, but what perfect square goes into 12? 4. Hold on. So I'm going to split that up into the square root of 4 times the square root of 3. So that's going to be 8 times 2 times the square root of 3, which gives me 16 square roots of 3. What about 75? What perfect square goes into 75? 25 times 3. So that's going to be 2 times 5 times the square root of 3, which is going to be 10 square roots of 3. All right, what about 28? That's not a perfect square either. What perfect square goes into that? 4 times 7. So that's going to be 3 times 2 times the square root of 7, which is going to be 6 square roots of 7. What's wrong with this one? The last one's not the same as the first two. That doesn't mean I can't do anything. That just means I can only combine the two that are the same. Okay. So the only ones I can actually combine together are my square roots of 3. What is 16 minus 10? 6. And because the second one is just the square root of 7, I cannot combine them, which means I cannot go any further. So therefore, I leave my answer just like that. Okay, so sometimes you'll have radicals that are not the same, so you cannot add and subtract them. You just leave them as one radical plus or minus the other. Everybody okay with that? We just have a couple more, but I got to throw some variables in it, right? All right. Let's take a look at 8. So we're going to separate these. Remember how we did it the other day where we put the numbers in one and the variables in the second one so we didn't have so much to look at? Okay, so let's start. Let's split up number 8. Let's split up the first one in number 8. We want to split it into the cube root of 8 and then the cube root of my variables, because then I can deal with those separately. Start with 8. Is that a perfect cube? Yes, what is the cube root of 8? 2. So that 8 is going to turn to a 2. And then we're just going to start dealing with our variables. Remember, we look at our index, starting with the x. How many times does that index 3 fit into 4? 1 time. Does it fit in evenly, or are there leftovers? There are leftovers, so those leftovers are going to have to stay under the radical. How many x's are left over? 1. Okay. Then we're going to do the same thing with the y. How many times does 3 fit into that exponent of 6? 2. Does it fit in evenly, or are there leftovers? Evenly, right? Yeah. Okay. So if I take that cube root of 8x to the 4th y to the 6th and I simplify it completely, I have 2xy squared times the cube root of x. Is everybody okay with that one? All right, let's do the same thing to 27. Let's split up the number away from the variable first. Is 27 a perfect cube? What's the cube root of it? 3. Okay. And then we're going to do exactly the same thing we just did. We're going to start with the x, looking at my index. How many times does that index 3 fit into the exponent 4? 1. Are there any leftovers? How many? 1. Okay. And then we're going to do the same thing with the y. How many times does that index 3 fit into the exponent 6? Twice. Any leftovers? No. When you have variables, just like if you were just combining regular like terms, all of the variables have to be exactly the same with exactly the same exponents as do the ones under the radical. So looking in the front, the first one I have is 2xy squared. Is that exactly the same as this coefficient? Okay. And then we need to look at the radical. I have the cube root of x and the cube root of x. Are those exactly the same? Yes. So I can actually add those together. What is 2 plus 3? 5. So it's going to be 5xy squared. All of the variables and the radical stay the same. The only thing that changes is the coefficient. If those exponents were any different or slightly different, then we would not be able to add them and we would have to leave them as they were. Are we kind of okay with that? All right, try that last one, number 9. Simplify each radical. And again, in order to be able to combine them, they have to be exactly the same variables with exactly the same. All right, again, split up your numbers away from your variables, then simplify. If everything is not exactly the same with the exception of the coefficients, if the variables and exponents are not the same, then once you simplify, you cannot do anything else. You will not be able to combine them together. Let's start with the numbers. Let me do this. We're going to do 16, and then we're going to split it up into x squared y to the 5th. Is 16 a perfect square? Yes. What's the square root of it? 4. All right, let's do our variables. Keep in mind, when the index is not there, it is a 2. How many times does 2 fit into 2? 1. Any extras or leftovers? No. Then we're going to do the same thing with the y's. How many times does 2 fit into 5? 2. Do they have any leftovers there? 1. Okay. So 16x squared y to the 5th is going to simplify to be 4xy squared times the square root of y. Is everybody okay with that first part? All right, then we're going to do the same thing for the second. We're going to split up the numbers and the variables. What is the square root of 4? 2. Okay, and then again, we're going to do the same thing with the variables. The index is 2 when it's not written. How many times does 2 divide into 4? Twice. Any extras? Nope. And then 2 divides into 3 how many times? Once, with how many extras? 1. So the next thing we have to decide is, can we actually combine these? I'm looking at my radicals. They're both square roots of y, but look at your variables in the front. I have 4xy squared and I have 2x squared y. Are those the same? No, so that means I can't do anything else to this. I cannot combine them because the variables and exponents are not the same. So we would leave our answer just like that.